In this example, we are given an acceleration function. So we have acceleration information of an object moving along a line. We want to find the position function with the given initial velocity and position. So remember that if you have a position function, s of t, and you do the derivative of it, you are getting a velocity function. And then if you do the derivative again, which is the derivative of the velocity function, you get an acceleration. So we are two derivatives in, basically, and we want to go all the way back to this original position function. Okay, so we need to do the integral, the antiderivative, twice to get back to this position function. But along the way, we're going to have that plus c. And so that's where this piece information comes in. It's very handy that once we do our antiderivative, we have a velocity information. We can figure out what the c value is, do the antiderivative again, and then figure out what your position function is. So if we have an acceleration function, our velocity function is going to be the integral of our acceleration, right? Because we're going to go here and we're going to go back. So we have to do the antiderivative to make that happen. So let's fill in what we know. We know that we are about to do the antiderivative of negative 32 dt. Okay, so the antiderivative of that is going to turn into our velocity function. And we're going to have a negative 32t plus c. All right, so here's where this information comes in. It says that at time 0, we have an initial velocity of 20. And so then we can plug in 0 and set our velocity equal to 20. So 20 equals negative 32 times 0 plus c. Perfect. C equals 20. All right, so we are sitting with our velocity function would be this plus our c value, negative 32t plus 20. Great. So now, in order to get from the velocity to the position function, we're going to do the antiderivative again. So our position function is going to be the integral of our velocity function. So we know that to be negative 32 2t plus 20. All right, so to get our position function, we're going to do the antiderivative of this. So we're going to have a negative 32. We're going to add a power to the t, divide by that power, plus 20t plus c. So if we simplify that a little bit, our position function is negative 16t squared plus 20t plus, we still don't know yet. That's where this piece of information comes in. So when we plug in a 0, we get a 2 out. So we'll do 2 equals negative 16 times 0 squared plus 20 times 0 plus c. So if we do all that math, we're looking at c equals 2. So those are just going to go away. So our position function would be, here's our position function before we knew the c. So negative 16t squared plus 20t plus our c value that we just got to be 2. All right, and that is how we have an acceleration function, and we have some other information about some sort of a velocity at a particular time and some sort of position at a particular time. We'll do the antiderivative to get to the velocity. We'll do the antiderivative to get to the position. And then along the way, we're plugging in this information to figure out the more specifics to our equation.